Hello students, this is Dilip Udhani and today I will teach you Laplace transform and inverse Laplace transform. So first of all, we will see what is Laplace transform. If f of t is a function of t defined for all t greater than or equals to 0, then integration from 0 to infinite e raised to minus st f of t dt is defined as the Laplace transform of f of t provided the integral exists and is denoted by Laplace of f of t. So Laplace of f of t, that is also f of s, that is equals to integration from 0 to infinite e raised to minus st f of t dt. So this is the fundamental definition of Laplace transform. Now we will see Laplace transform of some elementary functions. So first of all, we will take f of t equals to 1. To find out Laplace transform of f of t equals to 1, we will use this fundamental definition of Laplace transform. So in this formula, we will replace f of t by 1. So we have Laplace of 1 equals to integration from 0 to infinite e raised to minus st f of t is 1 and dt as it is. Now integration of e raised to minus st with respect to t, answer is e raised to minus st divided by multiplier of t, that is minus s, and the limit is from 0 to infinite. Now minus 1 by s, that is this one as it is, and put down upper limit first, that is infinite, and then after lower limit 0. So it will become e raised to minus infinite minus e raised to 0. Minus 1 by s as it is, and the value of e raised to minus infinite is 0, and the value of e raised to 0 is 1. And 0 minus 1, answer is minus 1, and if you will multiply minus 1 by minus 1 by s, the result is 1 by s. So we have Laplace of 1 equals to 1 by s. Now we will take f of t equals to t raised to n. So in the fundamental definition of Laplace transform, we will replace f of t by t raised to n. So we have Laplace of t raised to n, that is integration from 0 to infinite e raised to minus st t raised to n dt. Now to solve this integral, we will substitute st equals to x. So we have t equals to x by s. Now differentiating this equation, we have dt equals to dx by s. Now if t equals to 0, then x equals to 0. If we will replace t by 0 over here, so it will become s into 0, so the result is 0. So for t equals to 0, we have x equals to 0, and for t equals to infinite into some finite value, it will become infinite, so we have x equals to infinite. So limit is integration from 0 to infinite e raised to minus st is x, and replacing t by x by s the whole raised to n, and replacing dt by dx by s. So integration from 0 to infinite e raised to minus x as it is, it will become x raised to n dx, and divide by s raised to n into s raised to 1, it will become s raised to n plus 1. Now to integrate this function, we will use some special function, that is gamma function. So we have gamma n, that is equals to integration from 0 to infinite e raised to minus x x raised to n minus 1 dx. So by the definition of gamma function, this integral will become gamma n plus 1 over s raised to n plus 1. Over here you have to write down x raised to n plus 1 minus 1, and then after you apply definition of gamma function, so it will become gamma n plus 1 over s raised to n plus 1. If n is a positive integer, then we have gamma n plus 1 equals to n factorial. So replacing gamma n plus 1 by n factorial, we have Laplace of t raised to n, that is equals to n factorial by s raised to n plus 1. Now we will take f of t equals to e raised to minus at. So to find out Laplace transform of e raised to minus at, In the fundamental definition of Laplace transform, we will replace f of t by e raised to minus at. So Laplace of e raised to minus at, that is equals to integration from 0 to infinite e raised to minus st, and f of t is e raised to minus at dt. So this is equals to integration from 0 to infinite. This is e raised to minus st multiplied by e raised to minus at. So it will become e raised to minus of s plus a t dt. Now we have to integrate e raised to minus of s plus at. So integration of e raised to x, answer is e raised to x, and integration of e raised to ax, answer is e raised to ax by a. So according to that formula, integration of e raised to minus into bracket s plus at, it will become e raised to minus s plus at, and the multiplier of t is minus of s plus a, so you have to divide it by minus of s plus a, and the limit is from 0 to infinite. So for upper limit it will become e raised to minus infinite, and for lower limit it will become e raised to 0 and minus 1 over s plus a as it is. And in the definition we have s plus a is greater than 0, so s is greater than minus a. So s plus a is positive, and positive into infinite it will become infinite, and over here we have minus sign, so it will become e raised to minus infinite. And value of e raised to minus infinite is 0, so it will become 0, and minus e raised to 0 is 1, so it will become minus 1. Now multiply minus 1 by minus 1 over s plus a, so the result is 1 over s plus a. So we have Laplace of e raised to minus at, answer is 1 over s plus a. Now we will take f of t equals to e raised to at. Now in the fundamental definition of Laplace transform, we will replace f of t by e raised to at. So Laplace of e raised to at, that is equals to integration from 0 to infinite e raised to minus st, and f of t is e raised to at dt. So this is equals to integration from 0 to infinite. It will become e raised to minus st plus at. Now taking minus t common, so it will become e raised to minus of s minus at dt. Now we will find out the integration of e raised to minus of s minus a t with respect to t, and that will be e raised to minus of s minus a t divided by multiplier of t, that is minus of s minus a, and the limit is from 0 to infinite. Now minus 1 over s minus a as it is, and for upper limit it will become e raised to minus infinite, because s minus a is greater than 0, so s is greater than a, so s minus a is positive, and positive value into infinite it will become infinite, and for this negative sign it will become e raised to negative infinite. Then after minus, for lower limit it will become e raised to 0, and the value of e raised to minus infinite, that is 0, and the value of e raised to 0 is 1, so it will become minus 1 into minus 1 over s minus a. So the overall result is 1 over s minus a. So we have Laplace of e raised to at, that is 1 over s minus a, where s is greater than a. Then now we will take f of t equals to sin at. So in the fundamental definition of Laplace transform, we will replace f of t by sin at. So Laplace of sin at, that is equals to integration from 0 to infinite e raised to minus st, and f of t is sin at dt. Then after we have to integrate this function according to this formula. Integration of 0 to infinite e raised to ax sin bx dx, that is e raised to ax by a square plus b square, then after a sin bx, then after minus b cos bx. So to integrate this function, what we have to do in this formula, we have to replace a by minus s and b by a. So it will become e raised to minus st divided by minus s square plus a square. Then after replacing a by minus s, so minus s sine of replacing b by a, sine of 80, then after minus sign, and now replacing b by a, then after cosine of bx, so it will become cosine of 80. So replacing b by a. Now the limit is from 0 to infinite. So for upper limit infinite, it will become e raised to minus infinite. So it will become 0, and 0 multiplied by any finite value, answer is 0. Then after minus sign, for lower limit it will become 0 e raised to 0, and e raised to 0 is 1 divided by s square plus a square. Then after replacing t by 0, so it will become sine 0, and value of sine 0 is 0. Then after minus a, replacing t by 0, it will become cos 0, and value of cos 0 is 1. So 1 into minus a, answer is minus a. So now minus minus plus a into 1a, and divided by s square plus a square. So Laplace of sine 80, answer is a over s square plus a square. Now we will take f of t equals to cos 80. So to find out the Laplace transform of cos 80, in the fundamental definition of Laplace transform, we will replace f of t by cos 80. So Laplace of cos 80, that is equals to integration from 0 to infinite e raised to minus st cos 80 dt. Now integration of this function will be according to this formula, right? That is integration e raised to x cosine of bx dx, that is equals to e raised to ax over a square plus b square, and then after a cos bx plus b sine bx. Now to integrate this function, what we have to do, in we have to just replace a by minus s and b by a. Okay, so it will become e raised to minus st over minus s square plus a square. Then after a is minus s and b is a, so it will become minus s cos 80. Then after plus, replacing b by a, so it will become a sine, replacing b by a, so it will become sine 80, and the limit is from 0 to infinite. So if we put down t equals to infinite over here, so it will become e raised to minus infinite. So it will become 0, and if we multiply 0 by any finite value, answer is 0. Then after minus sign, now replace t by 0, so it will become e raised to 0, and e raised to 0 is 1. So 1 over s square plus a square. Now replacing t by 0 over here, so it will become cos 0 multiplied by minus s, and the value of cos 0 is 1. So 1 into minus s, the result is minus s. Then after replace t by 0, so sine 0 is 0, 0 multiplied by a, the result is 0. So the overall result is minus 1 over s square plus a square into bracket minus s. So minus minus plus s into 1, result is s, and divided by s square plus a square. So we have Laplace of cos 80 equals to s over s square plus a square. Here we will see f of t equals to hyperbolic sine 80. So in the fundamental definition of Laplace transform, we will replace f of t by hyperbolic sine 80. So Laplace of hyperbolic sine 80, that is equals to integration from 0 to infinite e raised to minus st hyperbolic sine 80 dt. Now we have one formula for hyperbolic sine 80, that is e raised to 80 minus e raised to minus 80 divided by 2 dt. Now multiply e raised to minus st by e raised to 80. The result is e raised to minus into bracket s minus a t. Then after this minus sign, now multiply e raised to minus st by e raised to minus 80. The result is e raised to minus of s plus at dt, and separate the integration. Now integration of e raised to minus of s minus a t dt, answer is e raised to minus of s minus a t divided by multiplier of t, that is minus of s minus a, and the limit is from 0 to infinite. This minus sign as it is. Now integration of e raised to minus of s plus at, answer is e raised to minus of s plus at divided by minus of s plus a, and the limit is from 0 to infinite. Now for upper limit, it will become e raised to minus infinite, and e raised to minus infinite is 0. And for lower limit, it will become e raised to 0. So minus e raised to 0 over minus of s minus a, and e raised to 0 is 1, and minus minus plus. So the result is 1 over s minus a. Now this minus sign as it is. Now similarly for this one, after simplification, we will get 1 over s plus a. Now we have to simplify this result. So finding the LCM, that is s minus a and s plus a. So in the denominator it will become s square minus a square, and over here it will become 1 into s plus a, result is s plus a, and minus of s minus a will become minus s plus a. So minus s plus s will cancel out, 1a plus 1a, result is 2a, and 2 will cancel out. So the final result is a over s square minus a square. So we have Laplace of hyperbolic sin et. Answer is a over s square minus a square. Now we will see Laplace transform of hyperbolic cos et. So to find out the Laplace transform of hyperbolic cos et, we will use the fundamental definition of Laplace transform, and in that we will replace f of t by hyperbolic cos et. So Laplace transform of hyperbolic cos et, that is equals to integration from 0 to infinite e raised to minus st, and f of t is hyperbolic cos et dt. Now we have formula for hyperbolic cos et, that is e raised to at plus e raised to minus at by 2 dt. Now multiply e raised to minus st by e raised to at, so that is e raised to minus of s minus at dt. Then after this plus sign and separate the integration, multiply e raised to minus st by e raised to minus at, so the result is e raised to minus of s plus at dt. Now integration of e raised to minus of s minus at with respect to t, answer is e raised to minus of s minus at divided by multiplier of t, that is minus of s minus a, and the limit is from 0 to infinite. And after this plus sign and integration of e raised to minus of s plus at with respect to t, answer is e raised to minus of s plus at divided by multiplier of t, that is minus of s plus a, and the limit is from 0 to infinite. So for upper limit infinite it will become 0, and for lower limit it will become e raised to 0, answer is 1, and minus minus is plus, so the result is 1 over s minus a. Now similarly, if you will simplify this one, then you will get 1 over s plus a. Now we have to find out the LCM of two factors s minus a and s plus a, so that will be s minus a, s plus a. 1 into s plus a, result is 1 s plus a. Then after plus 1 into s minus a, result is s minus a. Now plus a and minus a will cancel out. So 1s plus 1s, result is 2s, and 2 will cancel out. And s minus a, s plus a, that is s square minus a square. So Laplace of hyperbolic cos at, result is s over s square minus a square. Now we will consider some examples. Example number 1. We have to find out the Laplace transform of f of t equals to 0 when t is between 0 to pi, and f of t is sin t when t is greater than pi. So for this purpose, we will use the fundamental definition of Laplace transform, that is Laplace of f of t equals to integration from 0 to infinite e raised to minus st ft dt. Now applying the brake at pi, we have integration from 0 to pi e raised to minus st, and in case of t when it is from 0 to pi, f of t is 0. So over here write down f of t equals to 0 dt plus integration from pi to infinite e raised to minus st. For t greater than pi, we have f of t equals to sin t. So over here replacing f of t by sin t dt. Now this term will become 0. Now integration of e raised to minus st sin t dt, that is e raised to minus st divided by minus s square plus 1 square, and then after minus s sin t minus 1 cos t, and the limit is from pi to infinite. Now put down upper limit infinite, that is replacing t by infinite over here. It will become e raised to minus infinite, and e raised to minus infinite is 0. And if you multiply 0 by any finite value, the result is 0. Then after minus sign, now for lower limit pi, replace t by pi, so it will become e raised to minus pi s upon s square plus 1, and into bracket minus s, replacing t by pi, so it will become sine pi, minus replacing t by pi, so it will become cos pi, and value of sine pi is 0, so this term will become 0, and the value of cos pi is minus 1, and this one term as it is. So minus minus plus, and if you will multiply 1 by this term, you will get this term. So the final answer is minus e raised to minus pi s over s square plus 1. Okay, now we will see second example. We have to find out the Laplace transform of 1 over square root of t. So for this purpose, we will use the fundamental definition of Laplace transform, that is Laplace of f of t equals to integration from 0 to infinite e raised to minus st ft dt, and replacing f of t by 1 over square root of t, and square root of t, that is nothing but t raised to 1 by 2. So writing 1 over t raised to 1 by 2 as t raised to minus 1 by 2 dt. Now find out the integration of this function. We will substitute st equals to x, so we have dt equals to dx by s, and when t equals to 0 we have x equals to 0, and when t equals to infinite we have x equals to infinite. Now it will become integration from 0 to infinite e raised to minus replacing st by x, replacing t by x by s raised to minus 1 by 2, and dt is dx by s. Now integration from 0 to infinite e raised to minus x, it will become x raised to minus 1 by 2 divided by s raised to minus 1 by 2 into s raised to 1. So it will become s raised to 1 by 2 or root s. So 1 over root s, integration from 0 to infinite e raised to minus x, x raised to minus 1 by 2 dx. Now writing minus 1 by 2 as half minus 1. Then after apply the function gamma, that is gamma n equals to integration from 0 to infinite e raised to minus x, x raised to n minus 1 dx. So it will become gamma 1 by 2. So this whole integral become gamma 1 by 2 and divided by root s. And remember the value of gamma 1 by 2, that is root pi. So it will become root pi over root s. So writing this term as square root of pi by s. So this is the Laplace transform of 1 over square root of t. Thank you for watching this video.